Oh my goodness, Mr. Schmidt! Is it time already? Is it math time? Oh my gosh, I'm so excited. It's time for some math, and we have a game today, Mr. Schmidt.
Yeah.
What are we going to do?
Task, you will need fraction cards made from this set. And so they show us the set here.
Would you scroll down because I think we even have one.
Yeah. You guys have some cutting out to do.
Sweet. You guys get to do this. And so you can do it with your brother, sister, mom, dad, anybody inside of your household. Stay safe. Okay.
So here, what I'm thinking is this going to be printed on the back of their cards? So it may be.
Not.
So
make cards if you need to.
Yeah,
Come on, guys. You can do it on a little scratch paper.
Yeah.
Just not your dad's paperwork.
They may have left a blank page and I may have taken it out.
Yeah, maybe.
So hopefully there's a blank page where you need it.
Yeah, let's hope so.
Okay.
Okay, so let's read it. Okay, so it says, label the line plot below with 8s. Cut out and divide cards evenly between 2 players, laying them face down.
I'm going to scoot down so we can see the line that they're talking about.
Each partner will choose one of their face down cards and turn it over. The team will then add their fractions together. For each turn, each team will record their sum on the line plot. So Mr. Schmidt and I decided that we are going to model 2 for you.
And also I wanted to point out that situation of having teams with 2 partners on each team, that would happen in a classroom. So
yeah,
you're going to have to kind of make up the rules as you go on this.
Yeah, you know what, guys? I'm serious. You know what I would do is I would find one other person in the house, unless you are lucky enough to have a bigger family and have some people with some time on their hands that they're willing to help out and do this. But 2 people is awesome. Make it work.
And really, 2 people could just be both partners for their team, right?
Yeah.
Because you could choose 2 cards.
Yeah, why not? So, you know, I'm going to say, oh, we're team A now. Now we're team B. Whatever. It doesn't matter.
You want to scroll up or down now?
What I want to do right here, is I want to put this is, I'm going to put this 0/8 because it said to label it. So I'm going to say this is 1/8, 2/8, 3/8, 4/8, 5/8, 6/8, 7/8. What comes next, everybody? It's 1 whole, but it's also, how do we know? It is when the numerator and the denominator are the same. 8/8 is the same as 1 whole. Okay, perfect. Okay, so Mr. Schmidt.
Yes.
I am going to let you, because you always call me a big bully.
Oh.
And my kids know I'm not a bully.
See how she's calling me names?
I never monopolize anything. My kids know that. Right, I'm a sweet, delicate.
If you guys have seen the rocket launch video, you know she's a ham.
You know, I'm a delicate flower. I never take any time. So, pick a number. Just pick any number. Close your eyes. Pick a number. Okay, so Mr. Schmidt has, I'm going to put it over here. We're going to put it right here. Mr. Schmidt has 1/8. And I'm going to...
Okay, and I'm going to move the paper around.
I'm really going to close my eyes because he's a big cheater-weeder. And I'm going to go right there. And I have 1/4. I think I was
you guys will have it easier because you can cut them apart and flip them over.
Yeah, we're just modeling. So 1/8 and 1/4. So what we have to do now is we need to add them together to find out how much that is. So, 1/8 and 1/4. Now, I talked about that before.
Seems like we just did this in the other video.
I know. What is something that 4 and 8 will both go into? Well, I know that 8 goes into itself. 8 goes into 8 one time, right? Will 4 go into 8, Mr. Schmidt? Let me think about this. I'm going to do this over here. I have 4. And then 4 more is... Oh, my gosh, it does. It's so easy, Mr. Schmidt.
Yeah.
It's 8. Okay. So, 4 times what gave me that 8? It was 2. So, you remember what I said, guys? Whatever I do to the denominator, I do to the numerator. Let's be fair to everybody. 1 times 2 is 2. Okay. What did I do to that 8 to get 8? I multiplied it by 1. So I'm going to multiply the 1 by 1. 1 times 1 is 1. So Mr. Schmidt, because we are adding our 2 cards together, what is 1 plus 2?
Usually it's 3.
Okay. Usually,
yeah.
But yeah, if you're in Schmidt's studio, it might be all kinds of crazy things. But it is 3. 3/8. So what I'm going to do is I'm going to come up here, and I'm going to put a single X there.
And the reason we're doing that is why? Because it says it's a line plot, right?
Yeah.
We're making a line plot.
Yeah. So what you're going to do is you are going to continue this activity.
I think we should do one more.
Okay. Oh, one more.
Let's do one more.
Sweet.
Because I want...
Mr. Schmidt
just in case some of the parents maybe haven't heard of what a line plot is.
Okay, fine.
Okay. We're just going to show what a line plot is. And also some of our students, we left early, so...
I'm serious. Yeah, okay. Absolutely.
So I'm going to choose. I'm not looking, despite what she says.
He's looking. He's got 1/8 again, folks. What do you think?
Well, one chance out of 3.
Mr. Schmidt is cheating.
OMG.
Yeah, right. I chose 1/2. Really? Okay. All right, guys. We have 1/8 and 1/2. So, again, I know 8 goes into 8. I always looked at my big number. Well, yeah, that's definite. Will my small number go into my big number? 2. Let me count by my 2's. 2, add 2 more, 4, add 2 more, that's 6, add 2 more, that's 8. Sweet, it does. So, my common denominator in this case is going to be 8. So 2 times what gave me 8, Mr. Schmidt?
You would need 4 2's to equal 8.
Awesome. And so what I do to the denominator, I do to the numerator. So I'm going to multiply by 4 there. 1 times 4 is 4. That's how I find equivalent fractions. 1/2 and 4/8 are still the same amount. Okay. Now, 8 times what gave me 8? I'd multiplied by 1. So 1 times 1 is still just 1. Okay, Mr. Schmidt, we're still adding, right?
We're still adding.
Okay, so 1/8 plus 4/8 is...
5/8.
Da-da-da-da-da! 5/8. Okay, so I'm going to come over here. And I'm going to mark it right there. All right. So, it says each team should have 12 data points marked on their line plot. So I'm going to say you and your brother, you and your sister, you, your mom, you, your dad, you and your dog, whoever. Do it 12 times. And now, but be fair, close your eyes, pick some cards.
They're going to flip the cards over.
Yeah, you're going to flip them over.
And guys, if you see through the paper, just maybe color the back or something.
Be fair, be fair. Yeah. But do it 12 times and then see, well, which ones have really come up?
Yeah, that's going to be one of the questions, right?
Each team should have 12. Okay, perfect.
So let's look at the questions.
Yeah, let's look at it. It says, look at the line plot. Which value came up the most? Which value did not come up at all? Mm-hmm. Okay.
And you know what? This is going to be different depending on how your game goes.
Mm-hmm.
So everybody won't have the same answer.
Okay, so there might be a couple of them that don't ever come up.
Right. And that's another question on this list.
But Pickle Boy, Daniel G. I know you've already thought that through. You know exactly which one will never come up.
Yeah, and some of you other kids, Christian. Some, I mean, a lot of you guys. A lot of you guys probably already know.
A lot of my babies.
Some of the ones that can't come up.
A lot of Bakersfield City. Hey.
Yeah.
We raise no fools. Yeah.
Okay, so
you guys are awesome.
The tick marks on the number line correspond to eighths. Which of the eighths will never come up as a sum of 2 of these cards?
Yeah.
Why? So exactly what we were just talking about.
2 cards.
Yeah.
Well, which
so
one
if we look at our number line,
Which one can never come up? There's actually 2 of them.
Yeah.
Can never come up.
Because we have to look at the choices we have, and if we add 2 of those numbers,
oh yeah,
which of these
not gonna happen.
Which of these fractions would never come up as a sum? Okay.
Okay, so let's continue on. What was the next question?
D.
Okay. You want to improve the game so that it is possible for 2 fractions to sum 7/8. Name one fraction card that you could add to the deck and explain why your new card would now make it possible to have 7/8 as a sum.
Mm-hmm.
So, we have 1/8, we have 1/4, and we have 1/2. What could we add to the deck?
Mm-hmm. Here's our deck.
That we would come up with 7/8.
Well, so what I would do, Mrs. Schmidt, I would write down how many 8s each of these cards actually is. I mean, maybe I would write it on the side or something. I know that all of these cards are equal to 1/8.
Mm-hmm.
And then I know that all of these cards, how many 8s are these guys? Well, what would we have to multiply? We'd have to multiply times 2, right? So we know that these cards are worth 2 8s. And I'm not trying to do too much for you guys. I'm not going to solve it, but I'm just saying how I would start. Okay, how many 8s is 1/2 equivalent to? We have to multiply times what, Mrs. Schmidt?
4.
So then we have 4 8s. And that now I just need to know, okay, what's another card I could add to the deck where I could get 7/8?
Yeah,
by
because
choosing two cards.
if I add a 4 8s plus a 2 8s, that's going to be 6 8s. That's not going to work.
And they said to add a different card to the deck, right?
Yeah, so I'm just going to say we have to add a different card.
Right.
So what could you add to
one
the
fraction card
deck?
that you could add to the deck.
Yeah.
Okay. So there you go, guys. We started it.
I'm going to leave that for
Yeah.
you guys to plot and think about.
Yeah.
Because I think you can do it. Okay. Now this one is just like beyond silly, folks.
Well, and it's supposed to be. That's why it's called reteach, right? It's supposed to be easy. It's supposed to be an easier version of what you'd find in the book.
Okay, so follow these steps to subtract fractions with like denominators. Oh, we can do this. Subtract the numerator. Use the like denominator. Remember, denominator never changes in addition and subtraction. Write the difference in simplest form. Divide the numerator and the denominator by their greatest common factor. Okay, so, okay, I can see 1 here, Mr. Schmidt.
Okay, let's go down.
I'm just going to make it cheesy easy on myself, and I'm going to do number 2. So I see that 3 minus 1 is actually 2. So that's 2/4. So what they're asking us, folks, is that the simplest form? Is there anything that I can divide 2 and 4 by? Well, I'm going to say, I'm going to come over here and I'm going to do my greatest common factor. So what is my greatest common factor of 2 and 4? So you know how I like to do it. 2. Well, it's 2. 2 goes into 2 one time, so it's just 2.
And guys, why did we do that? Because 2 is already prime, so we don't need to factor it out.
Exactly.
Yeah.
And then 4. But I always like my kiddos to double check. You know, never just assume. You should know that, but if you don't, that's how you can check.
I already know 2 is the smallest prime number.
Oh my goodness. Okay, so what prime number will go into 4? It is 2 again. 2 goes into 4. How many times? 2 times. So there we are.
I just want to make sure they know when you guys are making factor, what do you call these? Factor what? Factor ladders?
Yes, they're called ladders.
Okay, so when you're doing that, you'll never have a 1 there in your factor.
No.
Because you never factored out to where there's a 1.
No, it's going to go to... 2 goes into 2 one time, but the 1 does not count.
Right.
Okay? So, the greatest common factors of 2 is 2. That's all there is. That's it. And then 4, it is 2 times 2. Remember what we've done before. Greatest common factor, I find my set of pairs. This one here is not involved because it doesn't have a match. So we're done. And then we just cross off 1. So what can we divide both of these by, Mr. Schmidt?
We can divide both of those by 2.
By 2. So I'm going to come up here and I'm going to divide both of them by 2.
Let me scoot so they can make sure they see it on the video.
Okay. All right. So 2 goes into 2 1 time. 2 goes into 4 2 times. So 1/2. And as we already know, 1 is not even a prime number. It's virtually nothing. And then 2 is a prime number. It's our smallest prime number. We cannot make that any smaller.
So I want to
it.
ask you a question then.
Yeah.
Mrs. Schmidt, how will you have them do the second step where it says draw a picture or use models to check? How would you do that for them?
Well, if I came up here and oh my goodness, Mr. Schmidt. Mr.
Well, they
Schmidt,
have to be able to see you're going to go off the edge.
Mr. Schmidt is always moving things on me. He's crazy, guys. Help me, help me, help me.
You see this abuse? You see this abuse I get, guys?
Abuse. Okay, so if I say 2/4, oh my goodness. Technology, guys, technology.
Just click. Yeah, just click.
Okay, guys, I'm cheating.
I'm thinking they might need scratch paper or something to do this.
Okay, so 2/4 and 1/2. So right here is 1/2. Okay. 2 parts. And but this
is not one hole.
4.
You have one hole on top of another hole? Yeah.
Yeah.
Okay.
So I have
these are like
right
fraction
here,
tiles.
2/4. Yes. Okay. And so I can say that 2/4 is the same amount of space as 1/2.
Cool.
Okay. So we can show it just like that. So nice and cheesy, easy. Mr. Schmidt didn't think I could pull it off. He's such a smart
Oh, yes, I did. I just wanted to make sure that we read the second instruction.
Yes, absolutely. I think you guys can handle this.
Okay.
So let's go ahead and move on, Mr. Schmidt.
All right. So let's look at this problem first, and then we'll scoot it down to look at the top.
Okay. So Rajesh what did he do?
Rajesh jogged 3/4 of a mile and then walked 1/6 of a mile. How far did he travel?
Oh my goodness. So, oh boy, he jogged for a while and then walked for a while. Mm-hmm. I'm telling you what, I would have walked 3/4 of a mile.
That sounds a lot like the problem we had the other day.
I know, right? This sounds like the jogathon thing or something. Yeah. Okay. So, what I'm going to do for you guys today is I'm not going to do the number line. But what I'm going to do is I'm going to show you how to set this up. And so we have, I'm going to come up here and I'm going to say we have 3/4. And then we have 1/6. Okay. And we want to know how much he did total. So again, we need a common denominator. Well, you know, my easy cheesy, can't believe how easy, let me cheat way is I like to say, oh, will my small number go into my large number? No, it won't. So what I need to do is I need to come over here and I need to find the least common multiple. In this case here, I'm going to do my 4s. My 4 is 2 and 2. Okay? My 6. What prime number will go into 6, Mr. Schmidt?
2.
2 goes into 6. How many times?
3 times, which is another prime number.
Yes.
That's why I said or.
These are prime numbers. So if I look at my 4s, what I have here is I have 2 times 2. And then for my 6, what I have is 2 times 3. Now again, I'm going to go and snatch up my pair. Okay, so I have that. And I'm going to cross off 1 because I only need 1. But if you will look here, this says least common multiple. That's different than greatest common factor.
So that could get confusing, right?
Yes. Now remember, with greatest common factor, I'm going to do a little quick one here. Greatest common factor, if I was looking at this and I said 4, and I had 2 times 2, and I had 6, and it was equaling 2 times 3. For greatest common factor, I would be looking for my pair. Okay? So for my greatest common factor, in this case, it is 2. Okay? But today, I am not looking for greatest common factor. I'm looking for least common multiple. So for least common multiple, what I want to do is I've scratched off the top. I left my 1 here inside of my pair. But for least common multiple, we don't leave anybody behind. We use them all. For our least common multiple, we actually we're going to use all of these.
So I have a question for you, Mrs. Schmidt.
2 times 2 times 3. Yes, Mr.
Does she do that to you in class, guys?
Absolutely.
Okay. So, on greatest common factor, we scratch out one of the 2's. Mm-hmm. But also on least common multiple, you did that.
Yeah.
So why did you do that for the least common multiple?
Well, because
I know why she did, but I just want to ask her to say it.
Because in the pair, what we are doing is we do not need a repeat here.
Aha,
so
exactly.
We are going to get rid of 1. Once we find our pairs, we are going to get rid of one of them because we don't need to have that repeat there. So we are going to do it this way here. So we have gotten rid of the 1 there, just like we do with the greatest common factor. Except for in greatest common factor, we are only sticking to what we have in our pair, which in this case is just 2. But for least common multiple, which is more friendly, we like to take all of our friends. So we're taking 2 times 2 times 3. So 2 times 2, folks, is 4, right? 4 times 3 is going to equal 12. So for my least common multiple, it is 12. All right? And I assure you, if I look at this here and I do my work over here and I say, Mr. Schmidt. If I say, if I do my counting here, I'm going to show you 4, 8, and then 12. And then I do my 6's, 6, and then 12. Guys, what is the common number that they have?
The smallest one that they have in common.
Yes,
which is the least common multiple. The least
common multiple is the smallest common multiple they have in common. So at what point do they have the same number? It is 12. So that is least common multiple and a review of greatest common factor. So we do have 12. What did I do to my 4 to get 12? I multiplied by 3.
Mrs. Schmidt?
Yes.
Are you going to solve this whole thing for them?
No,
okay.
I'm not.
Okay.
And then 3 times 3 is going to be 9. 6 times it's going to be 2, and then 1 times 2 is 2. And then you can add them up. Now, the reason why I went ahead and did that part for you is because you're going to come down here with the number line. Okay? And it says, show your solution on the number line. Well, what was the greatest common, or the least common multiple that we had?
Guys, I just want to point out, I made this beautiful number line for her. And did she thank me? No.
I did too.
She just picks on me and picks on me. Oh,
look at him. He made a beautiful number line for you to look at. So what you're going to do is you are going to start here. And I'm going to, yeah, that was nice, Mr. Schmidt.
You erased the number line. Okay, let me fix it.
Okay.
Wait. Let me see. I don't want her to erase it again. Okay.
Okay, so what you're going to do here, folks, because I want you to do the number line today, so that's why I started. We start with 0. Our least common multiple, our common denominator was 12. So we start with 0, 12. So we come over here and we start with, what is it that makes it a whole? Numerator and denominator are the same, so it's 12 12s. And we know somewhere in the middle it should be 6 12s. So what I want you to do is I want you to complete the number line, then go back up here. What do you have? You have 9 12s plus 2 12s. So, Mr. Schmidt. So what you're going to do, come down here, is you're going to find out, well, whereabouts is 9 12, and then add 2 12s more. Okay. And what did you end up with? Okay, I think that you guys can do this.
Did you want them to label all the tick marks for all the 12ths?
Yes, I do.
So they don't have to say whereabouts is 9 12ths, right?
Yes, absolutely.
They'll actually know
absolutely.
where it is.
Yes, I'm saying about where is it at because I didn't label it.
Okay.
But you're going to. I don't want to do all of the work for you. Right. So I want you to do that. We have done a lot of number lines for you. So I want you guys to have an opportunity to practice this by yourself. Okay.
And that's our last problem today.
Is that it, Mr.
That's
Schmidt?
it.
Oh my goodness, we are done?
Yeah.
Oh, man.
Yeah. Hey guys, don't forget, in the other video we were asking you guys to send in your pictures of rockets and the stories that you write or the descriptions that you write, the battle drawings and sketches. So guys, don't forget to do that. And if you guys send that in, we'll make a video and show it to everybody.
Yeah. Make sure you put your name on it and stuff, and man, we'll put it out there.
Yeah.
Let you guys see it. We're a family. We need to see each other.
Yeah.
Okay. All right. Well, have a great afternoon, guys. Be safe and be kind to your parents.
And we'll see you tomorrow.
Bye.
Bye.